Picture this. You're floating on the surface of the ocean, sun on your face, warm water beneath you. Peaceful, right? Now imagine sinking, just slowly sinking. 10 feet, 50 feet, 100 feet. The light starts to dim, the water gets colder, and somewhere below you, and I mean this literally, there are creatures that have never seen sunlight, not once, in their entire lives. But here's the thing that nobody talks about. The deeper you go, the physics of the ocean actually change. The rules that apply at the surface stop working, and what fills that void is something most people are completely unprepared for. By the end of this video, you're going to understand exactly why the deep ocean feels like a different planet, and why some scientists genuinely believe we know more about the surface of Mars than we do about what's down there. Let's start at the surface and work our way down. Because the ocean isn't just one big uniform body of water, it's actually divided into distinct zones, and each one has its own set of rules. The first zone, the one you're probably familiar with, is called the sunlight zone, or the epipelagic zone if you want to sound smart at a dinner party. This goes from the surface down to about 650 feet. This is where almost all ocean life you've ever seen lives. Dolphins, sea turtles, most fish, coral reefs. Sunlight penetrates here, which means plants can photosynthesize, which means there's food, which means there's life. It's busy, it's vibrant, it's familiar. Then you hit the twilight zone. This is where things start to shift, from 650 feet down to about 3,300 feet. Sunlight barely reaches here. It's not total darkness. There's a faint blue glow, but there's not enough light for photosynthesis. The temperature drops sharply. And the creatures that live here? They start looking different. You've got lanternfish, bristlemouth fish, vampire squid, things with massive eyes designed to capture every last photon of light. Things that migrate upward at night to feed and sink back down during the day to hide. Below that is the midnight zone. Zero sunlight, total darkness. Pressures that would crush an unprotected human being instantly. And it just keeps going from there. The abyssal zone, the hadal zone, named after Hades, the Greek god of the underworld, which should tell you something about the vibe down there. But here's what I want you to hold on to as we go deeper. Each zone doesn't just get darker, it gets fundamentally stranger, and the reason for that is mostly physics. Let's talk about pressure, because this is where the ocean starts to feel genuinely hostile. At sea level, you have one atmosphere of pressure pushing down on your body. You don't feel it because you've lived with it your entire life. Your body is calibrated for it. But every 33 feet you descend into the ocean, you add another full atmosphere of pressure. So at 33 feet, you're dealing with 2 atmospheres. At 100 feet, you're at about 4 atmospheres. By the time you reach the bottom of the Mariana Trench, the deepest known point in the ocean at roughly 36,000 feet, you're looking at over 1,000 atmospheres of pressure. That's like having 50 jumbo jets stacked on top of you. Now think about what that does to the human body. Your lungs would collapse, the nitrogen in your blood would become toxic, your eardrums would rupture almost immediately. And this isn't a slow process. At those depths, it would be almost instantaneous. But here's what's fascinating. Life figured out how to deal with this. Creatures in the deep ocean have bodies that are essentially designed around pressure. Many of them have no air pockets inside their bodies at all, because air compresses and crushes. Instead, they're filled with water or specialized fluids that compress equally in all directions. Some deep-sea fish have cell membranes loaded with a compound called thiamino that keeps their proteins from being deformed by pressure. The snailfish, which currently holds the record for deepest fish ever found discovered at nearly 27,000 feet, shouldn't be able to exist according to everything we used to believe about biology. And yet, there it is, casually living in conditions that would kill everything else on Earth. Now let's talk about the darkness, Because humans are visual creatures. We're wired to rely on light. So when you remove it completely, everything changes. Below around 3,300 feet, there is no sunlight. None. Ever. The darkness down there isn't like the darkness in your room at night. It's not like a cave with the lights off. It is an absolute, permanent, total absence of light. And yet, the deep ocean is not actually dark. Here's one of the most mind-bending things about the deep sea. Scientists estimate that up to 76% of deep-sea creatures produce their own light. This is called bioluminescence, and it works through a chemical reaction. A molecule called luciferin reacts with oxygen and it produces light. No heat, just cold, ethereal light. Now, why would creatures evolve to glow in a place with no sunlight? Because light still has value, even down there, just not for seeing the world around you. Some creatures use bioluminescence to lure prey. The anglerfish is the classic example, that nightmare fuel fish with the glowing lure dangling in front of its face. Other creatures use it to communicate with potential mates. Some use it as a defense mechanism, flashing bright light to startle predators, and some, like the counter-illumination strategy used by certain squid, use bioluminescence to match the faint light coming from above so they don't cast a shadow, essentially making themselves invisible to predators looking up from below. The deep ocean figured out how to use light in a place where light doesn't naturally exist. Think about that for a second. Evolution created its own lighting system in total darkness, and the results look like something out of science fiction. Okay, this is the part you've been waiting for. The creatures of the deep ocean are not just unusual, they are genuinely alien by any reasonable definition of that word. And the reason goes back to everything we've already talked about. When you're designing a body for extreme pressure, zero light, near freezing temperatures, and scarce food, you end up with body plans that look nothing like anything on the surface. Take the giant isopod. It's basically a roly-poly bug, the kind you find under rocks in your backyard, except it's the size of a football. Some of them. They scavenge the deep ocean floor, eating whale carcasses and anything else that sinks from above. They can go years without eating. Years. Then there's the barrel-eye fish. It has a completely transparent head. You can see through its skull. Its eyes, which look like green tubes, can rotate inside that transparent dome to look either forward or straight up. It uses those rotating eyes to spot the silhouettes of prey above it. The goblin shark, which is sometimes called a living fossil because its lineage goes back 125 million years, has a jaw that launches forward out of its face to catch prey. Its skin is translucent. You can see its blood vessels through it. And then there's the siphonophore. This one breaks people's brains a little. A siphonophore is technically a single organism, but it's made up of thousands of individual animals called zooids, each specialized for a different function: locomotion, feeding, reproduction. The largest known siphonophore measured 150 feet long. That's longer than a blue whale, and most people have never heard of it. We've only explored about 20% of the ocean floor, which means 80% of the deep sea has never been seen by human eyes. The things living down there, we genuinely don't know what they are yet. Let me take you to the bottom. The very bottom. The hadal zone begins at around 20,000 feet and extends to the deepest trenches on Earth. The most famous of these is the Challenger Deep in the Mariana Trench in the Western Pacific Ocean. At 36,089 feet, it's the deepest known point on the planet. To give you a sense of scale, if you dropped Mount Everest into the Challenger Deep, its summit would still be more than a mile underwater. Only a handful of humans have ever been to the bottom. 3 crewed descents. James Cameron made the trip in 2012. And when they got down there was life, microbial mats covering the sediment, small crustaceans called amphipods crawling around. Sediment that was soft and almost silky, the result of billions of years of marine snow, tiny particles of organic material that drift down from the surface like a constant, slow, eternal snowfall. There's something almost unbearable about that image. This place that seems like it should be the most sterile, dead, impossible environment on Earth. And it's covered in life. Life that has been down there adapting and evolving, completely separate from everything on the surface for millions of years. So, let's come back to the original question. Why does the ocean get creepier the deeper you go? And here's the real answer. It's not because the creatures are more dangerous. Most deep-sea animals are actually fragile. They're adapted for a specific stable environment. Bring them to the surface and many of them die within seconds as the pressure drops. The reason the deep ocean feels creepy is because it violates our expectations of what the world is supposed to be. We are surface creatures. We expect light. We expect consistent physics. We expect to be able to see predators coming. We expect biology to follow certain rules. And the deep ocean breaks every single one of those expectations. It's a world where darkness is permanent, where pressure would kill you instantly, where the rules of survival look nothing like anything we evolved alongside. It's the psychological uncanny valley of natural science. It's familiar enough to recognize as Earth, but alien enough to feel wrong. And our brains are wired to interpret wrong as dangerous. The ocean gets creepier the deeper you go, because deeper means further from everything human beings evolved to understand. And there's something humbling about that. This planet still has a wild, unexplored frontier. It's just straight down. We've mapped the surface of Venus. We've landed on Mars. We've sent probes to the edge of the solar system. And 80% of the Earth's ocean floor has never been seen. The deep sea is the last great unknown on this planet. And every time we send a submersible down, we find something new. Something that doesn't fit what we thought we knew. Some new creature, some new chemical process, some new form of life that rewrites the textbook. The ocean isn't just deep, it's deep in a way that still surprises us. If this kind of thing interests you, the hidden mechanics of the natural world, the places humans haven't fully explored, the science that sounds like science fiction, there's a lot more where this came from. The next video is already waiting for you.